Hello everyone, welcome to this session. In this session, I am going to solve one of the problem on the thermodynamic processes. The problem is that a cylinder contains 1 kg of a certain fluid at an initial pressure of 20 bar. The fluid is allowed to expand reversibly behind a piston according to a law PV raised to 2 is equal to constant until the volume is doubled. The fluid is then cooled reversibly at constant pressure until the piston regains its original position. Heat is then supplied reversibly with the piston firmly locked in position until the pressure rises to the original value of 20 bar. Calculate the net work done by the fluid for an initial volume of 0.05 meter cube and draw a neat PV diagram. Here in this one there are three processes are taking place. First one is that is the PV raised to 2 is equal to constant, that is a polytropic process with the initial value of the pressure 20 bar and its volume of the 0.05. Until that process takes place, till the volume is doubled. That is the process, first one. Then second one, after that PV raised to 2 process, polytropic process, the fluid is cooled reversibly. If that is cooled, then its volume will be reduces. And that is that by maintaining the constant pressure, piston to regain its original position. That means the volume should comes to the original volume. Okay, that is the piston position, initial position. That is the second process. Third process is the heat supply process. Heat is then supplied reversibly with piston firmly locked in the position until the pressure rises to the original value of the 20 bar. That means pressure will be increased, volume remains constant in this process. And for these three processes, we need to find out the work done, and then sum up all the work done we are going to add, then we are going to get this net work done by the fluid from the initial volume to the final value. And for that we have to draw the PV diagram. Continuation with this one, the first will take that is a PV diagram only. The initial, it is a first state 1 at the 20 bar pressure. Then it is polytropically expands, that is at PV raised to 2 is equal to constant. And the volume whatever is there, initial volume is V1 this one and final volume V2, the V2 equal to twice the V1. The initial volume is given 0.05, then the final volume V2 will be the 0.1. Then after that 2 to 3 process, it is a constant process, constant pressure cooling process till it regains the piston whatever is there, it regains what original position. Here the piston comes to this position. Then after the 3 to 1 process whatever is there, it is a constant volume heat supply process. Okay, the volume remains constant to this one only. Then the pressure increases, okay, to the original pressure of the 20 bar. These three processes will find out the work done. Then the sum of all this work done will give the total net work done. For this, the given data are the mass is given 1 kg and the pressure is given 20 bar, that can be written as 20 into 10 raised to 5 Newton per meter square. Then initial volume is given 0.05 meter cube. Then V2 is given as a 2 V1, it is mentioned in the numerical. That is twice this initial value will give the 0.1 meter cube. Then first we will take that is for polytropic process, 1 to 2 process, where work done is given by that is a W1 to 2 is equal to P1 V1 minus P2 V2 by N minus 1, where N is the polytropic index 2. Then now the P1 V1 square is raised to 2 is equal to P2 V2 raised to 2. Okay, this is from that curve we can get that one. PV raised to 2 is equal to P1 V1 raised to 2 is equal to P2 V2 raised to 2, because this equation we are going to use, because in this equation, work done equation, P1 we know, V1 we know, V2 we know, N polytropic index we know, and from this equation we can find the P2. That P2 equal to, therefore P2 equal to P1 into V1 by V2 raised to 2. Okay, that is P2 is equal to P1 multiplied by V1 by V2 raised to 2. That is 20 into 0.05, the V1, 0.1 V2 raised to 2. Then after the calculation we are going to get the P2 is equal to 5 bar. 5 bar we are going to get. Now after getting the P2 5 bar, then if you substitute in this equation, we are going to get the work done for the 1 to 2 process. That is, can have, hence W1 to 2 is equal to 20 into 10 raised to 5 into, that is a P1 multiplied with a V1.05, and 5 into 10 raised to 5 the P2 multiplied by the this V2, then by N is a 2 minus up 1. After the calculation W1 to 2, we are going to get the 50 kilojoule. The next process, for the constant pressure process of 2 to 3, work done is given by the constant pressure process, where the pressure remains constant and volume only changes. V3 to V2 to V3 reduces, volume will be reduces, that one, and that one V3 minus V1 we are going to take. Okay, here the negative work done on this one. Okay, the work done is a negative. That means here the volume will be reduces. Therefore, the pressure whatever is there, that is a pi into 10 raised to 5 multiplied with a 0.05 V3 multiply minus of the 0.1. And that after the calculation W2 to 3, we are going to get minus 25 kilojoule, because here the volume is low, the smaller volume is there V3 and higher value is the V2. Therefore, the negative work done on the system we are going to get here. Next one, for the constant volume process 3 to 1, work done is given by. Okay, that it, always we know that one, for the constant volume process the work done is 0, as V1 equal to V3, both the volumes are remain same. Okay, at firmly the piston, by keeping firmly held at that position, the heat addition is taken place. Therefore, here the work done equal to 0 for the constant volume process. Therefore, after that, hence net work done during the cycle, whatever we are going to get, that will be the sum of all this. W net is equal to W1 to 2 plus W2 to 3 plus of W3 to 1. Then that is 50 minus of 25 plus of 0. And finally, W net we are going to get 25 kilojoule. Okay, this is for the three processes net work done we can determine in this way. Thanks for watching. If you like, share, subscribe and comment.